welcome everyone to this month Connect with Remedy webinar series. This month we'll be talking about Remedy 9, optimizing and troubleshooting the AR Java stack for performance and load. During the webinar, if you have any questions, you can post them in the Q&A pod. And also during this presentation, there will be 3 opportunities for live questions on the content that's presented. At this time, I'd like to turn it over to Hugo Vuong, our presenter today. Thank you.
Thank you, Greg. Show you the agenda. Let me talk about the agenda. So the whole point of this agenda is because we moved on to the 9.0 platform, and that is 100% Java. Most of the talk will be about Java and the operating system. So the agenda is really optimizing, and in optimizing, we have to take the perspective that we already have something working the way we think it should work. Then we can begin to fine-tune and optimize it, okay? And troubleshooting goes hand in hand with tooling. And this is almost like a Sherlock Holmes kind of thing. Every time I go and work with a new case, I love it. It's like, you know, Sherlock Holmes. You go in and you don't know what's going on, and then at the end of the day, boom, you nail it. So the objective is for you to keep your deployed AR Java stack in top shape. Okay, here we go. This is the outline. Brace yourself. So the logical progression is at the OS layer. And then from the OS layer, I move on to the JVM layer, and then I will move to the application layer, okay? Then I'll talk about the tool, okay? So, wow, when you're going to talk about optimization, yeah, well, we'll talk about the tool first, and when you see which tool, then you know how to optimize and troubleshoot the stack, okay? And then, so that's exactly what I'm going to do. It's like visual interpretation of the data. What is idling? What's normal? And how do I know when it's resource bound? So then I'll show how to use the tools to take snapshots and thread dumps and heap dumps, and how to save and send it to us for support or analysis. But mainly what you can do yourself. Say, you know, what do I do with this, right? The garbage collection, GC in the JVM. So Java has garbage collection model rather than manual malloc and alloc and malloc and free like in the C model. Okay, and I will also include the G1 GC, which is the latest garbage collector that Oracle put out. Okay, then I will talk about the sizing, and then I will talk about the load handling, because a lot of people are skeptical of Java load. Okay, so first thing, you do need to worry about your operating system. Okay, here's the reason. This is a little technical, okay? You have to brace yourself for this. Okay, so in the old days, 32-bit, not a problem. Each memory page was about 4 KB, okay? That's it. Okay, so we say, what? What are you talking about? Why do I need to know about this stuff? Well, when you alloc, you know, a malloc in the C, and you get a pointer reference to your memory address, that's not physical memory. That is your logical memory, okay? And once that logical memory is there, it has to look through a table, a translation table, look up, and map that into physical memory. And you say, well, who cares? I don't need to know about this stuff. Maybe if you need, you know, a couple gig, you will, because if the memory page is a 4 KB, how many pages are there in 1 gig? Well, a lot, okay? And so your translation tables are so huge that the lookup process will begin to take time. Now, for the 10,000 users load, I'm running with 20 gig for my AR server. So you say, wow, that's a lot of memory pages. The answer is yes, a lot, okay? Well, that's one, okay? And then the other item is this, and you may have suffered from this all the time. You just don't know it. Windows sort of simplifies everything. It does your virtual memory paging. And when that page is paged from one memory page to the next page, it does a swap. You know, your HTTP request or whatever AR API request comes in, it will be slow. You know it, okay? So it turns out that there's a way to lock memory into your application. So what I'm saying is this. You have physical RAM, and you tell the OS, I want to lock this much RAM. Let's say you want 4 gig for your mid-tier. I want to lock 4 gig of RAM for my mid-tier, and that's it. So it will never swap out. Your 4 gig of RAM will be in resident all the time. And you can do this, okay? By the way, if you run Solaris, you don't need to do a thing. Everything's automatic, which is nice, but I figured that's one of the reasons why they swallow Sun. For the Linux, you can go here and if you run the 2.6 kernel, you can size your memory pages to a certain size. And then there's a good guideline there. So what I'm saying to you is if you run Windows Server, do yourself a favor and click on that first link. At the bottom of it, there's like 5 things you have to do. And it's so straightforward. You can do this in 5 minutes. To lock into memory, the physical memory, the chunk that you will need for your application, so it will never swap out. Okay, that's really first link, 5 minutes tops. Okay, Windows Server. Now, if you're on Linux, it will take a little more. Okay, but read up on that. So I'm just bringing awareness to you. Okay, that you can allocate larger memory pages than 4K byte. And the reason for that is the memory lookup, the translation table, memory lookup from logical memory into physical memory, okay? And then the other thing is how to lock memory, your physical memory, and reserve that for your application. Very easy to do. Read those 2 links. And, you know, I love the web. I can Google anything now, but there's a lot of misinformation too. Those 2 are really good. Read the first one, that's from Oracle. Read the second one, it will show you exactly what to do. Anyway, the first one will show you exactly what to do for your Windows Server, which is really easy, 5-minute job, okay? So now, the next one, this is a funny one. So out of the box, okay, if you're running a 32-bit Java application and all of a sudden you switch to 64-bit, you can guarantee pretty much you get like 15% drop in performance. And you say, well, what do you mean, 15% drop in performance? Well, overall, I would say that it's 15% slower, you know, that it's just purely due to the addressing. So Oracle or Sun, they do that up front. They say, wow, you know what, that's no good. We have to take care of that. So with the 1.7, 1.8, they said it's automatic, it's on. This mode is called a hybrid mode, okay? So what you see there says it's when you see a dash XX, that's a directive to the JVM. It's a JVM argument, okay? The plus means to force the use of compress oops, okay? Compress object pointers, okay? You see P for pointers, S plural. What this does is it uses really a 32-bit addressing system, but with a switch bank. So that will allow you to address up to 62 gig of JVM heap and still not suffer from the 15% degrade, okay? So I recommend to use all the time, okay? I just do it. I want it on, turn it on, add that to your JVM arc, okay? So all that does is says, you know, even though I'm on a 64-bit system, use a 32-bit addressing system. Okay, it's called hybrid. And you're good if you assign up to 32 gig of memory. You're good with that. Now the next thing, this is sort of, this is a good one. If you look in the JDK install, now you have a JRE. JRE is just the Java runtime environment. It's just the virtual machine itself, basically. There's absolutely nothing else in there. But if you install the JDK, you have a lot of tools in there, like JStat, JMap, you know, JNDI. What else? Keygen tool. You know, you can generate your own SSL certificate, import your certificate. So for developers, they always install the JDK, right? Now, I think the AR server just uses a Jerry install. And so you don't get this tool, the JVisual tool that I'm talking about here, okay? You need a JDK for that. So fortunately, this tool is a client-side tool. So what that means is you can run this tool on any of your client machine. In your laptop, for example, Now, as long as you can see the IP address of the target JVM, you can monitor it, okay, remotely. And that's the way I do it, because then you don't put any extra load on that machine that's running the JVM. Like, for example, I have a production environment. God knows, I don't ever want to touch it, right? So I just monitor it from the remote, right? And then someone will always say, but when you do the monitoring, doesn't that affect the performance? And the answer is yes, but it's so negligible. Okay, I'll tell you how negligible it is. When I publish my benchmark numbers, those are all collected with this monitoring on, because I refuse to run a benchmark without knowing what's happening inside my JVM. So I start the monitoring, run the benchmark, collect the monitoring data as part of my benchmark work. So all the benchmark numbers that you see on the web, that I'm going to show you at the end, are all done with the monitoring on, okay? Now, this is how to turn it on. In fact, I already did a step-by-step. So basically, you have to tell, when you do a -D, that's, again, the directive. The -XX is an option, and -D is a directive to the JVM itself. And this is to turn on the JMX remote protocol. And then you need an open port. And, you know, if you are highly secure with firewall, you need to open a single port that you can use. Now, for demonstration purpose, I would say SSL equals false. Okay, so it doesn't use any SSL. But if you have a production environment and it's not behind a firewall and you want to monitor the environment from your house, which I don't advise ever, because you don't ever open up any port, you know, people can sneak in, but you can turn on the SSL for the JMX, so you need to generate a certificate, import that into the key store of your JVM, okay? And then you need to indicate the credentials for login. I will show you when I run the tool. It'll ask me for all this stuff, okay? Here's the document that tells you exactly how to do this. So I'm not going to talk any more about that. But you have one thing in your favor. Okay, well, hang on. Give me a second. So right now, let's say you have your JVM running. You don't have to remote JMX on. So you need to put it in, right? Well, you can ask me, how do I do that? Well, look at the link. But anyway, if you're running Windows, there's a start script, the .bat or .shell script if you run in Linux or Unix, right? There's all the JVM arguments. That's where you put those in, okay? And then you have to restart your JVM for the argument to tag. So it turns out that the AR server already has RMI running, okay? So you can add JNDI running, so you can leverage the JMX using JNDI lookup to run on top of RMI, okay? So it turns out that if you have ARS running, you don't need to put those arguments in. If you look at this document here, it says that it opens this port, RMI port on 61,500, okay? Well, you change it. You have to change this URI here, okay? But that URI is what you need to know to connect. I'm going to demonstrate how to do that. So let me recap for a moment, okay? So what have I talked about so far? So far, be aware of the hardware that you're running, okay? That's your job, right? Now, when you run, one way to optimize the performance is to lock the physical memory to your process. And I gave you idea how to do that, okay? And then the second idea was to use the hybrid mode. And that's just turning on that flag for your JVM, the end. Nothing more to do, okay? Good up to 32 gig, okay? Now, where I'm going to now is the tooling. And the tool I'm talking about is the jvisualvm. It's already inside part of your JGK, or you can download a separate download. It's called visualvm, and it's an open source thing. You can download that package. Up to you how you want to deal with it, okay? But I like it because it's available with the standard JDK install, and I use that because I don't know what customers use for the system. Okay, so in order to use it, I like to use that remotely. So you do need to turn on this remote protocol here, okay? And then if you run the AR server, it already has RMI, so then you don't need to do it because we can leverage the JMX over the RMI, and we're done with that, okay? So that's it. That's the recap of what I have so far. Write things down. If you have questions, ask. Okay, let's move on. Okay, now once you hook it up, at this point I should hook it up and show you how it's running, right? But we'll get there. I can show you just opening a static file. I can show you the graph look completely different. You say, wow, really? Yes, really. So the graphing package, and most people don't realize it, the graphing package is only as good as the granularity of the graph points, right? And then a lot of graphing packages will try to interpolate, to make things look better, right? Like, for example, you have discrete points that tries to draw a smooth line or something like that. Well, it's good and bad. I mean, it's bad because it doesn't provide you with accurate data. I'm going to show you that, okay? So the only thing that I want you to keep in mind is that when you look at the graph, the only thing you can rely on is the trend of the graph. That's it. Don't rely on specific points. You can, but unless you know more information, and there's a way to get more information, don't do that. Just take the trend, and that's what I'm going to cover. Okay, I'm going to run the tool, launch it, show you the different trend that I see and where the problems are, and even show you the artifacts of the graphing packages, okay? And now, generally, because I don't know what the usage pattern is like, so I always ask the customers to collect the data for 24 hours so that I can see the peak and off-peak usages, okay? And lastly, this point is just to recap what I said earlier about the hardware. When I interpret the trending of the graph here, like the CPU trend, the x86, you can target about 60-75% interval. If you get over the 85% trend on the CPU, you will see degrade in service time, and that's something you don't want because you want your users to experience, good response time. Now, if you're on a Spark like a T3, T5, or T7, target under 20%. So it's just some guideline for you, but I think you can get more info from your vendor. In this case, probably Sun, Spark, Oracle, okay? I generally target the heap usage at 65% for user-facing machines. So I said web use cases, and the reason is you can never tell how many people coming in, so you need enough room there. And you can never tell what people do. Like some people can, well, you can put some safeguard in, like for example, don't let this person pull like 500,000 rows. But things like that can happen, so you want to target about 65%. That way your old generation is also less, smaller. GC is better. If there's a surge in heap usage, the behavior of the GC would be better. You can say, well, 65% of what? Okay, I'll show you the picture. Okay, this is a good one. It's a good one. Okay, let me look. Let me look to see where I'm at. I'm going to show you a picture. I think the last one on the 65%. This is a beautiful picture. This is the actual heap usage of a production system. So you can see that I target, well, this is, the interval is very short. It's only an hour, so you can't really see a whole lot. But this is where you like it to be. 65% is the most. You want the trend to be like this. And so if somebody comes in, run their reporting use cases, it can surge a little, but it'll come back down. You say, well, why the surge if I'm just doing reporting, right? Well, remember the old days when you had user tool talking to your server? Well, we use web. It's the browser talking to Meteor making all the AR API calls, pulling all your objects back. It has to do the object to HTML and JavaScript conversion, and that process is heap intensive. you have a bunch of data, and the same data representation has to be in two different formats at a time, right? One is in whatever you pull back from database, and the other one is in the format for the browser, HTML, JavaScript. So you really have two copies at any moment in time. That's the simplest way to see it. So when you do like reporting, the heap usages jumps up, okay? Or when you pull data, basically here has to have two copies at some moment in time. When you pull data, it pulls data from the database, has to convert that data into the HTML and JavaScript. So two copies. Okay, so this is desirable heap usage for standard use cases for the web, okay? I'm going to start running this tool, okay, because I run it all the time. I put it in my quick access here. I have two copies, okay? One is the 1.8 JDK. One is the 1.6 JDK. You can ask me why I do that, okay? Let me launch a 1.6 JDK first. Well, there's one thing that I should point out. I'm sorry. Let me go back to this for a second. So recap. We talked about hardware at the OS layer, okay? We talked about the tooling, how to hook up remotely, okay? And then how we leverage the RMI in the AR server, and I was about to demo how to hook up the tool, right? But one thing is this, sometimes some customers say, I have the problem right now. I want to see what's going on right now. I can't put those in and then restart because then the problem would go away. It would take like another 3 days before the problem shows up. Well, there's a way around that, okay? And the way is, if you go on the same exact machine and you launch a jvisualvm on the same exact machine, the two Java processes running on the same local machine will do the Java inter-process communication. So you can monitor anything on the same machine without adding these guys. Okay, that's what I want to show you. Okay, so let me go ahead and share that. That was the one thing I forgot to mention because I didn't put it on here. So I'm going to share monitor 1. Okay. And let me run the 1.6 first. Okay. I'll tell you the reason why I still have the 1.6, which I don't need anymore, by the way. The 1.6 has a built-in TDA. That's the Thread Dump Analyzer. And then with 1.7, 1.8, they yanked it out. They say, nobody knows how to use this tool anyway. It doesn't belong here, so they took it out. However, they have a download. You can download the plugin to do your, and then to install it inside your tool. And that's exactly what I did for 1.8. But I still want to show you the two copies here. Let me show you. So this is 1.6. I'm about to run this 1.6. Oh, let me open this up. Okay, excellent. Let me pin it here. Okay, so you can see, this is a funny one. Okay, so right here on my local machine, it says, oh, this is the process myself. This is the visual VM, right, the self process. And it says unknown application. That is my Eclipse running. And this is the funny portion, the funny part that you have to know, okay. My Eclipse is running using 1.7 at this moment in time, okay. My jvisual right now is running 1.6. The JMX protocol changes slightly, so it doesn't know that this is Eclipse. Okay, but let me go ahead and start the 1.8. But it's backward compatible. This is the 1.8 JVisual. So it's kind of backward compatible. Let me launch it. Okay, so the 1.8, it says, oh, this is myself. This is the other visual VM that you're running, and this is the Eclipse. Okay, so you can see that it sees everything. And go back to this 1.6, okay? I'm going to open one file for you. This is actual file, actual production data, and I remove all the relevant stuff. So it just says demo. Okay, I'm going to open this up. And this is what it looks like. That's the graph I took out for part of the slide. Okay, beautiful. This is good behavior. You see the trending is about here. You're using roughly 35% of the CPU. Okay, so in general, you can take note on this. You won't see degrade until the trend exceeds 80%. A degrade in use case performance time, okay? So in my lab, if I were running an x86 architecture and I do the benchmark and I want to maximize the number of concurrent users per web, I would push my load all the way up to here, okay, to about that, okay? So you can say, well, Hugo, right now it's about 25%. Does that mean I can double the load? Okay. My answer would be, well, it's a tricky question because load, it's a really tricky question. When I do the load, okay, this is how I measure my load. The rate of HTTP requests coming in per second, okay, because you can have like 1,000 users log on and they don't do anything. Nothing for it because each user session takes about 10K bytes out of my heap, okay? So you can put 1,000 users in there, no problem, okay? But if they're not doing anything, it's no good. So for me, my load is more like what is the rate of HTTP requests coming in and what is the average payload going out in terms of response. And that's sort of one metric that I measure, okay? But that might be too technical, okay? So a more practical or domain-centric approach would be, well, what type of users I have, right? So when I sketch up the ITSM workload, I work with an actual customer, and it goes, there's call center users, right? Those guys just log in and heads down, submit like, 5 tickets every 5 minutes, for example. I don't know what the rate is, but that's a good one. And then there are casual users where you log in and then you do FTS, knowledge search, and then say, oh, I have to file ticket, and log out, right? That's an entirely different type of users. So the ITSM workload that I have for the benchmark, and you can read all about that. I spell out. It's the first time that I can read a workload definition where I understand everything. Oh, this is type A user, type B user, what the behavior is, what the rate of submitting requests are. Okay, I'm going to give you that link at the end too, so you can go and check it out. An actual 10,000 users, okay? So the load is sort of a very interesting question. So someone says, if I have this right now, can I double my load? And the answer here, in this case, we use x86 architecture, is almost always yes. But you have to be sure that you have enough heap to accommodate that usage. And that would be a pretty reasonable answer. Okay? Unless you have load testing, load tool to play around with, that's the surest thing is, the secret in doing load testing is, remember, when you load test, you are trying to emulate real-life usage. So if your load test is not indicative of real-life usage, then you are scripting very bad load tests, okay? So my load test is designed in such a way that the server side can never tell the difference between real users and a load user. That's the way to do it, except for username, because I have mnemonic I use for fake users versus real users, right? So anyhow, that's the objective. And so, if you have a load tool, you just double your load. And double, I mean proportionally, right? Not, well, you think about it, how it applies to your context. And so the answer is almost always yes. In this case, you have enough heap. In this case, I would say yeah, most likely. Okay, but what I want to do right now is to open the same exact chart in the other tool. Okay. Okay, demo, right? And then you say, whoa, what's going on here? Look at this chart. It looks really busy, right? This versus this guy. So then you see right away what I mean about graphing artifacts, okay? So the only thing you can rely on is just the trending, okay? So that's what I rely on. Except for the threads. For the live threads, you can actually take numbers down here, okay? So the graph is pretty good for that. Okay. So, give me a second. So let me go back here, see where I am. So that's one thing. I'm losing my train of thought. So graph artifacts, trending in usage, problem. You will run into problem if there's already a problem. And I'm going to show you what kind of problem you will see. Okay. So let me go back to this one. It's a little bit cleaner. I'm going to open this next demo up. Okay. And this is where you can see. This is where the problems are. So first thing you look at every time you see the jaggy thing like this, that's all interpolation. That means that here, between here and here, you kept asking the JMX to give you data, but JMX says, I'm too busy. So it's not sending any data back, okay? So when you look at this, jaggies like this, you know that your CPU is having major issues. Mainly, it's not responding at all, okay? Well, I don't want to go here, okay, but we'll go there soon enough. 7.6, and it's true, 7.6, you give 3 gig, you're perfectly good, okay? But with the 9.0 version, the mid-tier uses more memory. Do yourself a favor, fix, and I will talk about fix heap allocation later, at least 4 gig, and that to support like 300 users on an x86 on 2 CPU running at least 2.5 gigahertz. That's about what you get. So I said, I can fix this for you, okay? First thing we're going to do is we're going to resize your heap, okay? And then second, this is where, you notice they do some thread dumps. You can see a lot of stuff here. This is why this is nice. You can see here. I can look at the spool. This is EH cache, by the way. If you don't know it, MIT uses EH cache. I can see a lot of spooling on, you see the percentage of spooling? 95%, 100%. So I said, I already see all these issues here too. I'm going to adjust EH cache for you so it stops spooling. So how EH cache work is, this is aside. This topic is completely aside, okay? But real quick, and then you can read a little bit about it in that document where I show how to hook up the monitoring. I talk a little bit about EH cache, do a fine text, EH cache. Okay, because now you have much more memory. You can give it more, and you can allow EH cache to cache more, and your performance will be way better. Okay, so I readjusted the EH cache, and I readjusted the heap, and this is exactly what they got. So I kid you not, that's a true picture of before and after. And they said, this stuff is flying. We've been running for weeks on end now. No problem anymore. Okay, so that was done. All right, let me go back here. See where we are. Okay, so let's recap this. Once we know the tool is available in the standard JDK, right? That's item 1. Item 2, we know how to hook it up remotely, follow that JMX protocol, or follow the document link that I sent, or if you're on the AR server side, hook up remotely using RMI. I will show you how to do that, okay? But then after that, note that you do have graphing artifacts, like, you know, sometimes it shows you like this stuff here, but that's not really the behavior, because that's just graphing behavior. They just draw a straight line to smooth things out for you. Okay, that's a graphing artifact, interpolation. Okay, so that's not really the actual behavior. Your JVM is not responding. Okay, all right, so you know that there's some artifacts involved. And then the best you can do is just leverage the trending of the graph. That's the best you can do. And for you, if you're on x86 platform, the trending here is you can shoot up to, you know, 75, but beyond 80% degrade in use case time, okay? For Spark architecture, keep it down here at around the 20% line. Anything above that, you see degrade in use case time, okay? So problem with deployment performance and JMX responsiveness, if the JVM like slow in responding, you end up seeing a lot of jaggy edges. Because, well, this is client-side collecting, okay? This is my client right now, and I'm about to do something, okay? Let's do this. Let's do this. So I'm going to connect to a real live AR server, okay, using the RMI protocol. All right, that's a pretty complicated URL, and I don't remember anything. So let me check this out. So this is the IP address for the AR server, and this is kind of cool. Give me a second. So remote, click on remote. I do everything from the left-hand side, okay? So for example, I can do, let me show you. Let me show you how I do this. So right-click, say add remote host, and put your IP address, and then you can display whatever you want, okay? Like for example, ARS demo for demo. Whatever you want, that's up to you. You can keep it the same, okay? So you see how it shows up as ARS for demo. Okay? So now, add the JMX connection. Remember, this tool here talks JMX protocol. That's it. Okay. So I can add JMX connection, okay? Now, if you put in that all these here, let me go back, give me a second. You see the port right here? That's the port you put in, and then the authentication information. So I would have to put here 1099, right? But remember, we're connecting to an AR server that didn't have all those ARG. I'm demonstrating how to write on top of the RMI protocol. So the URL looks like this, or like this, but I chose a simpler one, okay? You say, wow, that's pretty complicated. What does that mean? You can actually Google that. It says you're using the service and you want the JMX right on top of the RMI, and you want to do a lookup using JNDI, but you always have to specify where the JNDI service is. But if you don't put anything here, like in this notepad here, I put in an IP address here, you see? You can do that. You can specify, but you don't have to. If you don't, it will use this by default. Anyway, so there you have it. So you do need credential because the AR server runs, you need that, the admin person. Okay, that's good enough, okay? So there's the service, use this credential. It's the app admin credential. I'm going to save it. It'll pop up, you see, there it is. Now double click. Bring it up. This is a live system. Nobody's using it, okay? This is actually good. So you can see that's monitoring. Okay, now I want to show you something, a little something. So remember I told you to collect 24 hours worth of data? So let me show you how to do that. So in tools, options, by default it's always 60. So 60 is 60 minutes, right, 1 hour. So the interval, the max interval from here to here is 1 hour. So anything older than 1 hour just drops off the face of the earth, right? The same here. It just keeps track of 1 hour. But by changing to 1440, you say 24 hours. So it will, this tool will continue to collect data for 24 hours. And then you can take a snapshot. But you know what? Let me just pause, take question.
A few slides back, you talk about the ops setting. Can you explain a little bit more the difference between the plus and the minus? We're currently set for minus.
Okay, very good. That's a clarification question. Here we are. Okay, so this option will only apply to 64-bit JVM. Okay, so we're already there. Okay, by default, if you don't put anything, it should be plus. The plus means force the use of compressed object pointers. And this helps you, it's called hybrid mode with the performance degrade when, you know, with the 64-bit addressing performance degrade. So the advice is always have a plus. A minus is force do not use hybrid mode. That is always use full 64-bit addressing. Always use 64-bit addressing with a minus, okay? So if you go back and you ever have a chance, change it to a plus. But if you see instability, to upgrade your JVM, okay? All right, I hope I answered that question.
You did, thank you.
Hi, Hugo, there was a question on the chat. What tool you use for stress load testing?
The short answer is Silk Performer. The long answer is any tool that can simulate the set of request responses will work.
Can you show me how you configure the monitoring to do 24 hours again?
Yes. So when you look in the tools options, right, by default, if you don't do anything, this looks like this. That's what you see out of the box, right?
Right. Right.
And then you're going to have to do this. You're going to have to change this to 1440. Okay. For both of these guys, yeah. And then click OK, yeah. And that's it.
Thank you.
Actually, I have two questions, if that's okay.
All right.
The memory, you were saying a minimum of 4, was it 4 or 6 gigabytes?
4 for the mid-tier, yes.
Okay, we're currently at 3, not seeing issues, but you would recommend we bump it up 1 more?
Okay, if this is my standard rule of thumb. When nothing is broken, don't try to fix anything.
Okay.
Okay, next question. You have 2, yeah?
Yes, correct. Back a couple slides again after you set the JV parameters. I didn't understand what the second link was.
This link here?
Correct. The slide before this, we have those already set in our set.env file. Correct. We have all the... I just don't know what the next slide is.
The next slide. Oh, okay. So when you monitor, okay, I'm using this tool called jvisualvm to monitor my target JVMs, okay? So there are 2 ways to do this. One way is you set the JMX protocol so that you have to have that in. That's a sure way to monitor remotely. And then I say, fortunately, but in order to set that, you have to restart your JVM. I said, fortunately, the AR server already has RMI running, okay? So we don't have to do that. We can leverage the RMI service so we can write the JMX on top of the RMI. And that's what I did here for this demo over here. Let me share that again.
Okay, and this is if we did not already have those settings, those parameters set?
Yes, that's correct. If you don't have it, let me see. Oh, look at this. Look. So people already set this also. So watch how I do this. See, the port says 9086. So here it's the same exact ARS, okay? I'm going to add JMX protocol, but now I can also talk via port 9086. And remember, this is completely different from the other guy. The other guy was on 61500, which talks RMI, okay? This one talks JMX. There it is. And you can double click and monitor. Oh, it should open. Yeah, there it is. So you see this monitor here? It started at 917. This monitor here is started at, well, before 9 anyway. But they are collecting the same data. They're getting the same exact data from the same target JVM. Okay?
Okay, thank you.
All right. Take dumps and stuff, okay? This is actually quite easy, okay? So I'm going to share my screen again. I'm monitoring this guy live, okay? Remember, I'm one of those bonehead where I only use one method. That works for me, and that's it. Don't show me another alternate method. It's too confusing. My brain doesn't work like that. So I use this nav bar, okay? So when you select here, you can do right-click. You can take thread dump, heap dump, application snapshot. Everything's here, okay? Someone always comes and says, oh, but you can also go to a thread tab and do a thread dump test. I don't want to know that. Don't tell me, okay? So here we go. When to take what? Okay, this is the best analogy I can come up with, okay? What you're seeing right now, it's like you're watching a movie, a live movie in action, okay? But with a live movie, like for example, you see a car zoom by, well, what was the license plate? I don't know. You can't really tell, right? And the same thing with a movie, right? You can't really tell. So you can take a snapshot at that moment in time. Well, you can say, well, what snapshot are you looking at? Well, it depends on what you want, okay? Right now, if I take this snapshot, and I already show you, the snapshot, what it does is at this instance in time, this is what I have so far. This is just this picture of the movie so far like this, right? And it also captured the thread data, okay, all the threads data for me, like how long, what has been running. You can tell the legend down here, okay? And I use that to analyze. But what it does not give me is the call stack of each thread, and this is what's important. When I do, like, for example, I say, well, I see that it's being blocked on this lock here, but why? What trigger? So this is what you do. And this is what I say. If you ever believe or suspect that you have a bottleneck issue is like your CPU usage is low, your heap usage is low, but your performance is terrible. That's most likely a bottleneck issue. What you do is you select this, you right-click, you take a T-dump. I say thread dump as T-dump, okay? T-dump, take one picture at that moment in time. Say, what are you getting? It actually tells the JMX protocol to, I'm using 1.6, which is kind of funny because 1.6 parses everything out because it has a built-in TDA, thread dump analyzer. So it takes a little longer, okay? Bear with me for this one. I should have done with the 1.8, which has no TDA. So it tells the JMX, the JVM, say, for this instance in time, take every single thread that you have running, dump out the call stack for me. And that's what you get for T-dump, okay? So how many T-dump do you need? Well, I would say that when you experience problem, you taking T-dump is already too late, right? So if you suspect you have a problem, you're monitoring live. You see, this is the T-dump. You see my screen? This is, okay, this thread, and you see the call stack for every single thread? Okay. And actually, you can analyze it with the analyzer. We don't have time for that, but you can read up on the web, Google for a short tutorial on how to use the TDA, and it will give you enough. Usually, when I do a monitoring like this, I advise the customer, say, okay, you see this trend in behavior, right? This is the trend, okay? And you suspect that something about to happen, take a T-dump at that moment in time. And then wait for a little bit, like 5 minutes or so. If it happens again, take another T-dump, okay? Watch, I'm going to take a T-dump, okay? So it's before, after, whatever. And you say, well, I don't know, okay? Then just take a couple of T-dumps from me. Space them out, because a T-dump is give me every single detail on every single thread running at that given moment in time. Okay. And so when you do, and these files are really small, by the way. When you do 24 hours monitoring, the end result is 2 meg. See, it's loading, parsing, my dump. So now that I have 2 dumps, right? Now, 2 dumps is like having 2 photographs. Well, we have 2 photographs of a movie. It's not going to give me context, right, to interpret this. But if this moment in time, you right-click on here, take an application snapshot, and this is the cool feature. When you take an application snapshot, any T-dump that you took earlier will be embedded in it, okay? So then when I load this snapshot in, right, I can look at the T-dump at 9:20, and I can look at 9:20, and I can switch over here, timetable at 9:20, and then look to see exactly what other threads are doing, who's in sleep state, who's in running state, you know what I mean? And before and after. So the application snapshot gives me a context to interpret the T-dumps. So don't send me T-dumps by itself. I don't like that. Take a couple, spread them out, take a snapshot, send a snapshot, and here's how you save it. Select the snapshot, right-click, say Save As. And in this case, I'm just going to save anywhere. All right, let's save in the demo here. Hey. I see TOI. And then give it a good name. No. I bet. Do my window explorer here. Okay. Okay, the demo snap, it's 34K. You say, wow, really? Well, as I mentioned, you can take 24 hours, like 2 meg. It's not a big deal. So you can load that. Let me load that in. But let me load with the other tool, okay? the 1.8. Oh, I may or may not have the TDA plugin, but let me load it here. Demo snap. Oh, perfect. So here they are. So when I load it, it shows me the 2 thread dumps here. And if you have the TDA plugin installed, as I did here, you can click on here and it will load your thread dump, and then you can analyze it. But let me go back. So far, this is what you should know how to do. You should know how to take a T-dump, take snapshots, okay, save and send, okay? So for the GC, it turns out that, oh, everything's already written, but here's the key important aspect. If you can keep this slide, I know I do screenshots all the time if no one sends me a slide deck, okay? I know people do that. This is a good summary. If you have low pause, GC, this is what you set for young generation, old generation. Throughput GC, this is what you set, okay? The G1 is considered throughput. Oracle recommend to use it at 6+ gig, okay? But what I recommend is always use a low pause, and that's inside our config checker already. It turns out that when I use G1 GC, fine, you get a lot of reclaim of your heap, but the use case times degrade, and that's no good because when I run as a service, I want use case times to be optimal. And then lastly, there's a defect up to and including the current JDK 1.8 version. By default, the new ratio, that is the ratio of the young to old generation, should be 2. That is 1/3 young generation, 2/3 old generation. That's 1 to 2, right? That's the number 2. It's not set. You have to do that. Okay, so right now, go back to any of your JVM, and you don't see it, put it in, because I can guarantee you there's a defect. And so you say, well, what does that mean in terms of performance? It means that your young generation is too small, and so it has a lot of false promotion into the old generation, and your garbage collection is working overtime, cleaning all the false promotion there out, okay? Now, you can look this up, okay? I broke this up into heap sizing for small model, medium model, and large model. And take a picture of this if you like, how many users there are, okay? And then what the settings should be for small model, medium model, large model in terms of hardware, in terms of your JVM ARCs, and your Tomcat service configurations here, okay? The pooling, this is the pooling. The mid-tier keeps a pool of AR API connections. So that's good. That's the second slide. Continue on for the configuration of the AR server, like how many threads for the fast queue, how many threads for the, but the last one, this one is really important. If you running AR server now with Oracle, and you notice that, hey, with the Java version, the heap just grows and grows, and then the JVM crashes. Well, it turns out that there's an issue with the JDBC. By default, it would take infinite memory. And if you have a poorly tuned SQL, like one that should be indexed, but you did not, this will cause your heap to crash. I mean, your heap to grow and your JVM to crash, okay? So a quick solution is to pass this argument to the JVM, limit the buffer size to 1 meg. So in the lab, when I ran this against the benchmark, the degrade in use case times is about 10%. 10% degrade in use case response time. But 10% is not a lot to pay if it can stop your JVM from crashing. Now, in the meantime, the real fix is to get the AWR, check your top SQL, and do your analysis and do your indexing there, okay? So this is a very important, but only for those people running poorly authored applications in terms of non-optimized indexings for the database query. And then you just need to limit the JDBC, Oracle JDBC client buffer size there, okay? And I think I'm done. I can open. Right, so lastly, if you go to this link here, this is everything I did for the 10,000 concurrent users load in terms of hardware, in terms of what I did for the AR servers, in terms of tuning, and what I did for the mid-tier in terms of tuning, what I did for the database, like, you know, how much SGA to set, PGA to set, and all that. Everything's there. And you can read all about the workload, too, like how many users of what type, what sort of, how many tickets they submit per hour, and so on. Okay, that is the place to go. And I can guarantee you I have zero reservation. If you come to me and say, take the 9.0 stack, can you deploy it for 100,000 users, concurrent users? I say, okay, give me some time. I will work with you. I have zero reservation. In fact, I love it so much more than the C++ model because I can see how the threads, everything, I can see absolutely everything I need to see. So including when you have poorly authored filter workflow, server-side workflow in AR server, I can see bad stuff happening inside at the JVM layer.
I'd like to thank you for your attendance and participation in today's Connect with Remedy webinar. Today's recording will be posted to the BMC communities within 2 weeks. Take care and have a great rest of the week.